What if Albert Einstein's absolute greatest mistake wasn't about the math at all, but happened just because he was born like a century too early to play online video
I
games?
mean, it sounds like a joke, right?
Right. But think about it for a second. We treat fundamental physics like this unshakable architecture. We measure the speed of light, we map the stars, and we just assume we have the absolute unchanging rules of reality completely locked down.
Yeah, we take it as gospel.
Exactly. But today, we're jumping into a conceptual landscape that suggests our entire spatial map of the universe is just, well, fundamentally flawed. And all because early 20th century physicists didn't understand server lag.
It is an incredibly ambitious premise, to
Yeah,
say the least.
it really is. Welcome to the deep dive, everyone. Our mission today is to unpack this highly unconventional, honestly mind bending blog post. It's titled Draft: Einstein Slacking 129 Weaving Coordinates from Mathematical Ideas, and it's by an author known as Zionad 2023.
And this text, it basically attempts to weave together Einstein's theory of relativity, 1980s Atari video games, the military hierarchy of ancient Chinese warlords, and,
Don't forget the obscure 1920s physics experiments.
right, those two. It's a lot. But before we really get into the mechanics of this, I do need to set a clear boundary for you, the listener.
Yeah, that's important.
The source material we are examining today heavily critiques mainstream physics, specifically Einstein's special relativity. So, as your guides on this deep dive, we are strictly impartial here.
We're neutral.
Exactly. We aren't here to endorse these alternative theories,
Right.
and we aren't here to debunk established physics either. Our role is just to act as translators, helping you map out this highly provocative worldview presented in the original text.
Just laying it out there for you to chew on. And the hook here is undeniably fascinating. The author basically believes Einstein missed a foundational reality of human perception.
He had a blind spot.
Right. And to understand why, the text actually takes us back to a historical conflict between two absolute titans of physics, Hendrik Lorentz and Albert Einstein.
Two very different ways of looking at the world.
Yeah, they're both trying to figure out how light behaves, and they both use that classic thought experiment, the moving train.
So let's break down the mechanics of that train experiment, because honestly, it is the foundation of the author's entire argument here.
Okay, lay it on me.
Imagine a train car moving forward at a constant fast speed. Now imagine someone inside that train turns on a flashlight, pointing it toward the front of the car.
Simple enough.
In the late 19th century, Hendrik Lorentz approached this using a framework that assumed the existence of an ether.
The ether, right.
Yeah, this invisible stationary medium filling the entire universe. It's what light waves supposedly travel through, much like sound waves travel through air.
So, in Lorentz's view, the train is physically pushing its way through this external ocean of ether.
Exactly. It's moving through a physical space.
Okay, so if light has a set speed limit through that ether, let's just call it c, and the train is moving forward at speed v, a passenger measuring the light inside the train shouldn't measure it as just c. I mean, they're moving along with the light, right?
According to Lorentz, yes. They would be measuring an apparent speed.
Apparent speed.
To use basic numbers just to make it easy, if the light travels at 100 miles per hour and the train is moving at 20 miles per hour in the same direction.
The person inside sees it moving at 80.
Right, 80 miles per hour. That is c minus v. Lorentz believed the measurement inside the train was completely dependent on the fact that the train and the observer inside it were both moving through a larger, objective external space.
So, the author is saying Einstein basically looked at the exact same moving train and fundamentally disagreed with that whole setup.
Completely threw it out.
He didn't care about an external ether. He essentially treated the train car like a perfectly soundproof, windowless room, right? Like the rules inside are absolute. Whereas Lorentz saw it more like a flatbed car moving through an actual external environment.
That's a great analogy, yeah. The author points out that Einstein declared the inertial frame, the train itself, to be a completely closed mathematical system.
Cut off from the outside world.
Exactly. For the observer inside, the laws of physics are absolute, and the speed of light is always a constant c, regardless of how fast the train is moving relative to the tracks outside.
And the author has some pretty strong words for what Einstein did here, right?
Oh, very provocative phrasing. The text argues that Einstein enslaved or subjugated light to his coordinate system.
Enslaved light. Wow.
Yeah, by drawing this artificial boundary around the train and just declaring it a closed system, he forced the speed of light to conform to his mathematical model.
So the critique is that this wasn't an empirical observation of physical reality.
No, it was a mathematical rule being imposed upon reality. Einstein severed the localized observer from the broader universe.
Which brings us to the author's wildly modern diagnosis of, why Einstein made this alleged error in the first place.
This is where it gets fun.
It wasn't a failure of calculus. It was like a generational blind spot. Einstein didn't play online video games.
He didn't understand the digital experience.
Right. So he didn't intuitively grasp lag or information delay. And the author brings up this incredibly specific example.
The arcade in Tokyo.
Yeah. Standing in an arcade in Sangenjaya, Setagaya, playing the Atari 5200 port of the classic game Missile Command.
I love that they specify the exact Atari port.
Yeah.
But Missile Command, for those who don't know, is a 2D game. You defend these little cities at the bottom of the screen from raining missiles.
Classic arcade setup.
The author uses this exact setup to build a completely new model of spatial coordinates. When you were standing there looking at the flat 2D arcade screen, you were observing what the author labels the XY plane.
Okay, the flat screen.
Right. Geometrically, this plane sits at a coordinate of, let's say, z equals 0.
But you aren't inside the screen. You're the player, so you're standing back from the glass. Your eye, the actual observer, is positioned away from the screen, back at a coordinate of z equals 10.
And that physical distance, that gap between z equals 0 and z equals 10, introduces the critical concept of information delay.
The server ping.
Exactly. The light emitted by the LED pixels on the screen takes a tiny but very real amount of time to travel through the air to reach your eye.
Because light has a finite speed.
Yes. So the image you are perceiving in your brain, the present state of the screen, is actually a historical state.
That is so wild to think about. By the time the visual information of that digital missile reaches your eye at z equals 10, the game's internal processor has already moved that missile to a new location on the z equals 0 plane.
You're always living in the past.
Okay, wait, I want to push the boundaries here because I'm processing the scale of this claim.
Go for it.
So the author is arguing that the entire physics industry basically maps space without accounting for the universe's server ping.
That is the argument, yes.
That physicists use light to define time and length, but completely forget that the observer and the observed plane might be moving through a larger medium, which would cause the light path to curve like a ball thrown on a spinning carousel.
That is exactly the analogy the author uses, the Coriolis effect.
Okay, explain how that connects.
So, if you are standing on a spinning merry-go-round and you throw a ball straight across to a friend, the ball travels in a straight line through the air. But to you and your friend on the ride,
It looks like it curves dramatically because you're rotating out of the way while the ball is in flight.
right, the author applies this exact logic to light. If the arcade cabinet, the player, and the Earth itself are all hurtling through a larger cosmic medium.
At electromagnetic ocean.
Yes. Then the light traveling from the z equals 0 screen to your z equals 10i isn't actually taking a perfectly straight path relative to the absolute universe. The starting point and the ending point are drifting while the light is in transit.
So the continuous beam of light arrives at your eye at a slightly altered angle.
Exactly. And the author argues that mainstream physicists are blind to this spatial drift because they assume a straight, instantaneous line in a closed mathematical box, like Einstein's train.
Okay, I want to pause here because the text makes a massive thematic leap that I really need you to walk me through.
The historical figures.
Yeah, I'm looking at my notes, and the author suddenly pivots from Atari video games and Z-coordinates to ancient Chinese military commanders.
That's quite the transition.
I just cannot figure out how Han Dynasty warlords map onto an arcade cabinet. I mean, why go there?
It seems like a bizarre non sequitur, I know. But the author uses these historical figures, Liu Bang, Xiao He, and Han Xin, to propose a new way to structure spatial recognition.
Okay, how does that work?
Well, if reality is warped by information delay and spatial drift, how do you accurately map it? You need a hierarchy of observational perspectives. The author maps the three ancient figures onto three distinct layers of perception.
All right, let's test this model. Break down the hierarchy for me. We start at the ground level, right? With Han Xin.
Right. Han Xin was a legendary field commander. In the author's spatial model, Han Xin represents the local observer situated right on the z equals 0 screen.
So like the little missile battery in the game.
Exactly. You only see your immediate, localized 2D surroundings. You are locked in the flat plane, reacting to events as they happen right next to you, completely unaware of the larger space or the delay of information.
You're just a pixel doing your job.
Right. Then we pull back to the second level, which is Liu Bang,
The Emperor.
the Emperor, the boss. He represents the player standing at z equals 10. When you look down at the z equals 0 battlefield, you have a much broader view than Han Chen.
But, and this is the kicker, you are subject to the information delay.
Yes. The light from the battlefield takes time to reach you. You are making decisions based on a historical reality, managing the lag between what just happened and what you are seeing now.
Which means Liu Bang doesn't have the objective truth either, right? Because he isn't accounting for the fact that the entire arcade cabinet is moving through space.
Spot on. For that overarching view, we need the third tier. Xiao He.
It's a strategist?
Xiao, he's the chief strategist, the information analyst. The author places him in a highly distanced, overarching coordinate, say, z equals 100, x equals negative 100, y equals negative 100.
Way out there.
Way out.
Sure.
Xiao He isn't just watching the flat battlefield. He is observing the entire system. The z equals 0 screen, the z equals 10 player, and the physical space between them, all moving together through the larger universe.
So Xiao, he represents the objective absolute coordinate system.
Exactly.
It's honestly like looking at a corporate org chart.
Oh, how so?
Well, if you only look at the universe through the eyes of the ground-level employee, Han Chen, you'll never understand the true dimensions of the company that the distant CEO, Xiao He, sees.
That's a perfect way to look at it.
And the author thinks mainstream physics is basically stuck at the employee level.
Or, at best, the middle manager level with Liu Bang. The author connects this directly to a concept you might recognize from theoretical physics. Minkowski's light cone.
Oh, right. Hermann Minkowski, he developed the geometric model of space-time that Einstein used.
Right. A light cone is essentially a 3D graph.
Yeah.
The vertical axis represents time from the past up through the present into the future. The horizontal axis represents 2D space.
And the cone shape itself represents the boundary of how far light can travel to reach a specific point in space-time.
Exactly. And the point where the past cone and the future cone meet right in the middle, that's the absolute present, time 0, t equals 0.
And now.
The author argues that true theoretical physics cannot just passively accept the light hitting the observer's eye at t equals 0. Mainstream physics, according to the text, just takes t equals 0 for granted.
They don't check the ping.
Right. To find the objective reality, physics must act like a psychoanalysis.
Psychoanalysis of light.
Yeah. You have to take the light rays hitting you right now at t equals 0 and trace them backward down the Minkowski cone through the information delay to where they originated in the past, say t equals negative 10.
Oh, wow.
And then you have to calculate the spatial drift of the universe during that delay to reverse engineer the actual historical coordinates of the event.
So you have to integrate Zhao. His overarching view to correct Liu Bang's lag. That is an incredibly elegant conceptual framework.
It really makes you think about perception differently.
But, and this is a big but, it's entirely theoretical at this point. I mean, to claim that there is a true map, that this external cosmic medium or ether actually exists, and that the Earth is actively moving through it, causing this light to drift, the author needs empirical proof.
You can't just rely on arcade cabinets and Han Dynasty metaphors.
Exactly. And this is where the text basically leaves the video games behind and digs into some highly controversial physical experiments from the 1920s.
Yeah, this is where we get into the Dayton-Miller experiments. The text leans heavily on the ether drift experiments, conducted by physicist Dayton Miller at Mount Wilson Observatory between 1925 and 1926.
Okay, set the scene for me. Why are these experiments so significant?
Well, to understand that, we have to look at the historical context. Mainstream physics history generally dictates that the famous Michelson-Morley experiment in 1887 definitively disproved the existence of the ether.
The invisible ocean.
Right. Michelson and Morley essentially tried to measure the speed of light in different directions. The logic was, if the Earth is flying through an ether ocean, there should be an ether wind blowing against us.
So light traveling into the wind should move differently than light traveling across it.
Exactly. But they found nothing. A completely null result. Light moved the exact same way in every direction, which eventually paved the way for Einstein to say, look, the ether doesn't exist.
But Dayton Miller didn't buy that.
No, he didn't. He believed Michelson and Morley failed because their laboratory was essentially in a basement near sea level. Miller thought the ether wind might be obstructed or dragged along by the Earth's surface down there.
Ah, so he needed altitude.
Right. So Miller took his equipment to the top of Mount Wilson, aiming for a clearer path through the cosmic medium.
The blog post actually includes these detailed images of Miller's equipment from his original papers, and I mean, the sheer scale of the apparatus is wild. He built this massive, intricately insulated machine called an interferometer.
It's a beautiful piece of engineering.
How does this thing actually measure an invisible wind? Like, mechanically?
The mechanism of an interferometer is brilliant.
Ah.
It takes a single beam of light and splits it into two separate beams using a half-silvered mirror.
Okay, a split beam.
Right. One beam travels straight ahead, while the other is reflected at a 90-degree angle. Both beams travel down these long metal arms, hit mirrors at the very ends, and bounce back to recombine at a central viewing point.
So if the Earth is completely stationary, both beams travel the exact same distance in the exact same amount of time, and they recombine perfectly.
Correct. And since light travels as a wave, with peaks and troughs, if the beams return at the exact same time, their waves align perfectly. But if the Earth is moving through an ether wind, the beam traveling parallel to the wind will be slightly delayed compared to the beam traveling perpendicular to it.
Because of the drag.
Yes. So when those two beams recombine, their waves are out of sync. The peak of one wave might overlap with the trough of another. This creates a visual pattern of alternating light and dark bands, which physicists call interference fringes.
Okay, so you can actually see it.
Yes. By measuring the shift in these visual fringes as he physically rotated the massive machine, Miller could calculate the speed and direction of the ether wind.
I'm looking at the photos of his setup at Mount Wilson. He didn't just put this highly sensitive machine out on a mountaintop. It's built on deep concrete and wooden platforms, and the entire thing is surrounded by a specialized tent.
A very necessary tent.
Made of canvas and beaver board, which, I looked it up, is a type of compressed wood fiber board. He even covered the metal supports in 1-inch thick cork panels and enclosed the actual light path in glass and paper. Why all the intense insulation?
Was he worried about the physical wind on the mountain shaking it?
That's what I thought.
No. The primary enemy of an interferometer isn't just physical vibration, it's temperature.
Oh, heat expansion.
Exactly. Critics of early ether experiments argued that tiny heat fluctuations in the air, or even the warmth of the scientist's body, would cause the metal arms of the machine to expand or contract by microscopic fractions of a millimeter.
And when you're measuring the wavelength of light,
A fraction of a millimeter ruins all your data. It creates false fringe shifts. So Miller heavily insulated the entire apparatus to basically eliminate thermal expansion as a variable. He wanted to ensure that any fringe shifts he saw were strictly the result of the light interacting with the ether wind.
And according to the author's citation of Miller's 1933 summary paper, Miller did not find a null result. He actually found the wind.
He did. The findings cited by the author are astounding. The graphs included in the source material show clear periodic shifts in the interference fringes.
Wow.
Miller concluded that the ether wind definitively exists. He calculated that the Earth has an absolute speed of about 10 kilometers per second through this ether.
10 kilometers per second, which is roughly a third of the Earth's known orbital speed around the sun.
Right. And he didn't just find a speed, he plotted a trajectory.
Yeah, the text says Miller calculated that the entire solar system is moving toward the Dorado constellation, the Large Magellanic Cloud, or potentially toward the Dragon constellation, Draco.
That's right.
But wait, how do you find a specific constellation with a light-splitting machine inside a cork tent on a mountain?
It's a great question. It comes down to comparing civil time with sidereal time.
Okay, unpack that.
Civil time is solar time, our standard 24-hour clock based on the sun. Sidereal time, on the other hand, is star time. It's based on the Earth's rotation relative to the distant fixed stars.
Got it.
As the Earth rotates on its axis and orbits the sun, Miller's mountaintop interferometer constantly pointed in different directions relative to the wider cosmos, and Miller tracked his fringe shifts around the clock, across different seasons.
Ah, I see. So if the ether wind was just caused by, like, the Earth's local atmosphere or the sun's heat warming the tent, the strongest readings would peak at the same civil time every day.
Like always at noon.
Right.
Exactly. But Miller found that the strongest ether wind readings peaked according to sidereal time. The interference fringes shifted the most when the machine was physically aligned with a very specific distant coordinate in the sky, regardless of where the sun was.
And that coordinate pointed toward the Large Magellanic Cloud.
Yes. Miller argued this proved the wind wasn't some local temperature anomaly. It was the entire solar system sailing through a universal medium.
Which really brings the author's argument full circle. If Miller is right, the universe has a server room, and we are moving through it at 10 kilometers per second,
And that means Einstein's closed box math
where light never experiences drag or drift.
is fundamentally severed from physical reality. The author heavily implies that mainstream physics just ignored Miller's findings because Einstein's math was too mathematically elegant to abandon.
The modern taboo. The text even references a YouTube video featuring Rupert Sheldrake to drive this point home.
Yeah. Rupert Sheldrake is a biologist and parapsychologist, mostly known for his concept of morphic resonance.
Right, he challenges scientific orthodoxies.
He does. And the author uses Sheldrake's discussion of the modern taboo within the scientific community against questioning the constant speed of light. The implication is that institutional physics locked in the speed of light as an absolute constant by definition and simply stopped checking for the server ping.
They just accepted it as dogma. I mean, wrap your head around this synthesis. We have a theory that bridges Atari 5200 missile command, ancient Chinese warlords, and 100-year-old graphs comparing sidereal and civil time.
It's a lot to take in.
All of it woven together to argue that our fundamental definition of a second and a meter is flawed simply because we are sailing blind through a cosmic electromagnetic ocean.
The author is attempting a breathtakingly ambitious synthesis here. The goal is to build a conceptual bridge between the highly localized, delayed reality of human perception, the Han Xin perspective, and the overarching objective geometry of the cosmos, the Xiaohe perspective.
Merging the pixel and the CEO.
Yes. By failing to integrate the simple concept of information delay, a gamer's lag, the author argues physicists have mistaken the closed boundaries of a mathematical equation for the actual moving reality of the universe.
And for you, the listener, whether this specific ether theory ultimately holds up to rigorous scientific scrutiny almost isn't the point.
No, the value lies in the intellectual exercise itself.
Right. It forces us to step out of the comfortable architecture of textbook physics and question our most basic assumptions. How do we define the now? How do we integrate different perspectives from the local to the cosmic to find the truth?
It serves as a powerful reminder that our models of reality are, at the end of the day, just models. When you trace the mechanisms of how we perceive space, you realize how much of reality is constructed by the limitations of the observer.
I mean, if the author is right and the light reaching your eyes right now is just delayed information from a constantly moving universe, how much of what you consider to be your present reality is actually just a server lag illusion compiled by your brain?
It's a haunting thought.
It really is. Next time you look up at the stars, or even just look across the room, ask yourself, are you seeing the universe as it is? Or are you just a player staring at a screen waiting for the universe's ping to catch up?